Hello all, my name is Ayush Bisar from class 8 and today we'll be talking about chapter 11 of our maths textbook, Mensuration. Let's get started. So let's get started. Today this is chapter 11, Mensuration, and as we're talking, first we will discuss perimeter. It's just revising what we have learned, like we have already learned the perimeter formula for square, rectangle and triangle. Now we'll be taking this forward to a circle and parallelogram and revising what we have studied already. The formula for square is 4a, that was 4 into side. Rectangle is 2 into L plus B, where L is length and B is breadth. So the formulas, first we add the length and breadth and then multiply with 2. Triangle. Triangle is simple, we just add all these sides. Then circle is 2 pi r. You multiply 2 with pi. The value for pi is 22 by 7 or 3.14, and r is radius. So it is 2 into 22 by 7 into radius. And parallelogram is 2 into a plus b, where a and b are adjacent sides. So these are the formulas. Now we'll be going forward and seeing the area of these three shapes. So these are the formulas for the area of square, rectangle, triangle, circle, parallelogram. The square is a square, that is side into side. Rectangle is LB, that is length into breadth. Triangle is 1 by 2 into B into height. That means we multiply 1 by 2 into base into height. Circle is pi r square, that is 22 by 7 or 3.14 into the radius square. And parallelogram in the last is breadth into height. Base into height. So we multiply base of the parallelogram with the height. Now we'll be seeing about semicircle. So basically, everything of semicircle is related to circle. Like because semicircle means a half circle. So if you talk about the perimeter, it will be the perimeter of circle divided by 2. So it's 2 pi r divided by 2. But here we have to add the diameter, because when we talk about semicircle and a circle, so this is the semicircle. When we talk about the circumference, we don't include this. But when we talk about the perimeter, we include this. So when we talk about a circle and find its circumference, we don't add the length of the diameter. But talking about the semicircle here, when we use this formula, we only get this curved part. But here we are talking about the perimeter, so we have to add this diameter also. So it is 2 pi r divided by 2 plus d, that's diameter, and then the area is pi r square by divided by 2. So we find the area of this. In the area, we don't have to add diameter or anything, because it is simply the area of the full circle divided by 2. We get this part. So the area of semicircle becomes pi r square divided by 2, because pi r square is the formula for the area of a circle. Now we will move forward and see how to use these formulas. Okay, now take this example. Take this to be a field. And we have been asked to find the area of this field. This field is not a rectangular, but has a curved part in the end. So we just divide them. If we divide them, we will find that this is a rectangle and these two are semicircles. And then we have to find the full area. We find the area of these two semicircles and add it with the area of the rectangle. And this is how we find out the area of this ground. Now for example, we will take another. We have been asked to find an area of this shape of a field. In this shape of field, here the shape at one end is curved and another end it is a type of triangle. So we'll divide them. This becomes a semicircle and this becomes a triangle. And then we can find the area of each of the shapes and find the total area. This is how we use the areas. Now we'll go forward and see the totals, the area of some other special quadrilateral that we have learned. So these are the area of three special shapes. Um, Trapezium and rhombus are special shapes, and general quadrilateral. If any general quadrilateral or of any different shape of different type comes, then we can use this formula. So talking about trapezium, it is 1 by 2 into a plus b. A plus b are the two parallel sides, as you can see in the diagram. This is one parallel side, this is another parallel side, into h. That's the height. Height means the distance between the two parallel sides. So 1 by 2 into the sum of the parallel sides into the distance between the parallel sides. So it is 1 by 2 into a plus b into h. Now talking about general quadrilateral, it's 1 by 2 into its diagonal h1 plus h2. h1 is this perpendicular. Now take this to be a, b, c, d. Then this diagonal connecting c and d is a diagonal. This cd is a diagonal. And h2, that is a to the this connects a to the diagonal, and this is a perpendicular line, that is h2, and this shows d is connecting to the perpendicular line, so this is h1. So that means 1 by 2 into the diagonal into the perpendicular of other sides to the diagonal, that is h1 plus h2. So next is rhombus. Rhombus is 1 by 2 into diagonal 1 into diagonal 2. So as we know, rhombus has two diagonals. And as you can see here, there are two diagonals. One is denoted as D1 and is D2. So the formula for rhombus is 1 by 2 into its first diagonal into its second diagonal. So these are the formulas. Now we'll be seeing how this is usually used in normal life. Let's look here. First, the first diagram shows that there's a field of a trapezium side and there's a road passing by it. So this is a real life problems when these come through, and this is in the shape of a trapezium. So first, when we find it out, these two are the parallel sides. So this is A, this is B, and this is the height. So we have to multiply 1 by 2 into A plus B into height, and this is how we'll get the area of the field. Now take this is an octagon, and when we divide the octagon, because there's a direct formula for octagon, we divide it for finding easier methods. So when we divide it, we find out that this is a rectangle, this is trapezium, and this is another trapezium. So we find the area of each of these and then we add them. Now we're going and seeing how to find the area of some polygons. So here are some of the polygons. This is pentagon, hexagon, and octagon. We know that quadrilaterals and triangle can be found out from the formulas, but the other polygons cannot be. For example, pentagon. Pentagon has to be divided for making its area, like for finding its area. When we divide, one becomes the triangle, one becomes square or rectangle based on which type of pentagon you're given. So we find the area of the triangle, then add it with the area of the square. I'm talking about hexagon. We can simply divide hexagon to get two trapeziums. We can find the area of these trapeziums and then we can add them. But for example, if you are not given the lengths that are required for finding the trapezium, we can further divide it. We know this is the H. This is one perpendicular to this line. So as we have seen for the formula of general quadrilateral, we know for finding the area, we take a diagonal and then we add the perpendiculars. Now take this to be A, B, C, D, E, F. So we have four perpendiculars, and as we know, perpendicular lines are those connecting one side to the diagonal. So according to general quadrilateral formula, it will be 1 by 2 into h plus 2, h1 plus h2, if there are two perpendiculars. Here there are four perpendiculars, so it will be h1 plus h2 plus h3 plus h4 into the diagonal. So when we do this, we find the area. The same thing can be done for this, but this is for a more better understanding. This is a different way. This will give us a rectangle. Here we get two triangles, and here we get a rectangle again. But here it will be a trapezium, rectangle, trapezium. But when we again don't get the length that was required, we divide it further so that we can get a better, like we can get it easily. So we get rectangle and then we get again triangle and another triangle. This might take time, but when we for finding polygons, we have to divide them into triangles or trapeziums and find the area and add them. Now we'll move forward and see some important properties of 3D shapes. A slight correction, sorry. So when we talk about hexagon, hexagon is not a quadrilateral. So the general quadrilateral formula cannot be applied on this. So sorry for my mistake. When we talk about a hexagon, again it's divided. When we see this is triangle, this is triangle, this is a rectangle, this is a rectangle, again triangle and again triangle. This will take time. But if, for example, we get the important things that we need for a trapezium. Here we can see that this is a trapezium and this is a trapezium. So when we get the important details like the length of this and the height between them, we can find out the trapezium. And then we can find out the area of two trapeziums. And if it's a regular hexagon, then both the trapezium will be of equal area. So this is how we find out for hexagon. Sorry for my mistake again. So when we talk about surface area is the area of the surface of any 3D shape. For example, here we take cube. Cube has 6 sides, 6 faces. So we have to find the area of each surface. So that means 6a square. We find the area of each square, each face of the cube, and then multiply with 6 because there are 6 faces. Total surface area means including all the sides. For example, we want to paint the whole room, including the roof and the ceiling. So a cube room, a cube room, cubicle room has 6 faces: right, left, front, back, the floor, and the ceiling. When we want to paint all the 6 sides, we have to find the area of each side and multiply it with of the side and multiply it 6 into 6 because there are 6 faces. And when we talk about lateral surface area, so for example, we want to paint only the walls. No, walls don't include the floor and the ceiling, and walls include our left, right, front, and back. So when we want to paint all the 4 sides, it becomes 4a square because a square is area of one square and 4 because there are 4 walls in a cube. So 4a square. Now talking about cuboid. To take we have a cuboidal room and we want to paint the whole room again, including the roof and the floor. So we took 2 into LB, that's length into breadth, plus BH, breadth into height, plus HL, that's height into length. So that we can see that there are 3 values: height, length, breadth. We multiply them with each other in different combinations. So we get 3 combinations, that's LB, length and breadth, then BH, breadth and height, then HL, height and length, and then we multiply with 2. So this is the formula for finding this total surface area of a cuboidal room. When we talk about lateral surface area, like for example again, we want to only paint the walls of a cuboid room. Then we do 2 into L plus B into H. We can see here that 2 into L plus B is the perimeter. It is the perimeter of the of a rectangle, and then we multiply it with the height. So for lateral surface area, we find out the perimeter 2 into L plus B and multiply it with height. Even here you can see the 4a. 4a is the perimeter of a square, and we take 4a square because here it's area. Now we take cylinder. Cylinder is mostly used in finding the area of gas cylinders or tin cans. So here we can see that total surface area of a cylinder is 2 pi r into r plus h. So here r is the radius, pi is 22 by 7 or 3.14, height will be given, and 2. So here we can see that this is a cylinder. Here we have a radius, this is the radius, and then here is a height. This is called a right cylinder because if you see, the height is perpendicular. Now for example, we take this type of cylinder. Here the height is not in 90 degrees, it's in a different angle. So because of this reason, this is a different cylinder. We'll be only talking about right cylinder, which is given in textbook, has been discussed. So this is a right cylinder. Here the formula for total surface area, that including the cap, the bottom, and the curved walls, it is the total surface area, that is 2 into pi r in bracket r plus h. So first we add the radius with the height and multiply with 2 pi r. Okay, now curved surface area. Curved surface, here is lateral surface area, because here they are a flat surface. But here is curved surface area, because when we talk about cylinder, two sides are flat and one, the middle part, is a curved surface. So because of this, we call it the curved surface area. Now when we want to find the area of the curved part of the cylinder, we take the formula 2 pi r h. Here we can see what is 2 pi r. Even here we can see what is 2 pi r. 2 pi r is the formula for finding the perimeter of a circle. So here that means we find the perimeter and multiply its radius plus height. Here is the perimeter plus height. Here also it's the perimeter plus height, and here it's perimeter into height only. But here height is equal to the other sides. That's why it's a square. For example, when we talk about a cube, all sides are equal, right? So that's why even its height is same as the side. That's why we take it as a square. So this is its surface area. We'll be seeing how this is used in day-to-day life. So the most common type of question which comes related to lateral surface area is they ask the lateral surface area or a total surface area of a shape. Like they give a shape and the dimensions, and they ask, like for example, you have an object, a box of which can be cylinder, I mean cube in shape or cuboid in shape, and they're asked to find the total surface area or the lateral surface area of that box. So these are the most common, like finding the surface area of a object. Now for second, the more another common questions that come is finding the lateral surface area, total surface or area of a room. Now for example, I gave you the example during teaching that the total surface area comes when we talk about all the six phases. We know that cube and cuboid have six phases. So we talk about six phases when we talk about the whole room, including the floor and the ceiling. So when we want to paint it, we use the total surface area. When we want to paint only the walls don't include the floor and the ceiling, we use the lateral surface area. And talking about cylinder, most questions come related to tin cans, or they come related to the rollers, the instruments you use in a roller, the cylindrical part in a roller. Such questions are asked. Now we move forward and see volume and capacity. So these are the formula for volume of cuboid, and cylinder. Again, we can find here that it is here for in finding cube, it is area into height. So for example, here we can see that is area into height. Even here we can see LB into height. So here also it's area into height. And here again pi r square. That's the formula of find of area of circle, and that's again area into h. So there are some common ways of finding. Now, for example, they would have given you the area of the circular part and finding the cylinder. So normally when we do this, we do area into h. Now, when we talked about the surface area, it was perimeter into height. When we talk about volume, it is area into height. So this is how it's common. So cube is a cube, that is the three sides of a cube, that is the length part, the breadth part, and the height part. But because all of them are equal in cube, it's a cube. That's a the side cube. Now cuboid. Cuboid is L into B into H. That is length into breadth into height. And cylinder is pi r square into H. That's 22 by 7 or 3.14 into r square into H. This is how we find out the volume of cuboid, and cylinder. Now we'll be seeing how do we convert, what is the relation between volume and capacity, and how it's used in our day-to-day life. So these are the conversions and uh, the relation between volume and capacity. So the volume is the the part which it encloses inside it. Capacity is how much quantity it can keep himself. So volume refers to the amount of space it has occupied, and capacity refers to the quantity that the container can hold. and the conversion is 1 centimeter cube equals to 1 milliliter. So likewise, when we multiply 1000 centimeter, 1 centimeter cube, we get 1000 centimeter cube. So 1 milliliter equals to 1000 milliliter, which is 1 liter. So 1000 centimeter cube equals to 1 liter, and 1 meter cube equals to 1000 liters. So if you remember this one formula, then from this we can find the other formulas. And when we talk about how volume and capacity are used in day-to-day life, it's very common. For example, they'll ask, we have a room, it has given the dimensions, and it'll ask, find the volume of the room. Or they'll give you a shape or an object, and we have to find the volume of the object. Then, if you talk about capacity, they would have given, for example, aquarium, and they would have given the dimensions. We find the volume, and using this formula, we find the capacity of how much water the volume can keep it with itself. So this is where volume and capacity are used. Capacity is used in finding how much water or fluid or whatever the object can keep with himself, and volume is how much space it is taking. So here our chapter 11, mensuration, is completed. There are very important formulas in this chapter which you should remember while solving problems. Thank you very much.